All right, welcome to 12.7, normal distributions. So now we're going to, 12.7 is all about one way in which probabilities can be used in our daily lives. There is something called the normal curve that is used often, especially in psychology, but in other fields as well. When we have a set of data and it has something called a bell-shaped distribution, we can use the area under the curve and a certain pattern to determine probabilities. This is also related to something called the standard deviation, which I will say more about in a little bit. So the normal curve is basically the same thing as the bell curve, if any of you have taken psychology yet. So it's a bell-shaped curve showing the distribution of responses. So for example, if I asked people, and it is always something that has a number response, so if I asked people, what is your height? I could use a bell-shaped curve to represent the height in the human population. Not all sets of data can be displayed in this way because not all sets of data follow this pattern. But a lot of human characteristics follow a specific kind of bell-shaped pattern, which is why it's so often used. When I have this bell-shaped curve, the area under the curve represents a probability. So the area under the curve represents probability, and the total area under the curve adds to be 1. So all of these little pieces are going to have a different probability, and they all add to 1. So 1 representing 100%. Alright, so here's what will happen. I have my set of data. Whatever the average of that data is will be the number that is represented in the middle. And the mathematical way of representing average, or the mean, is x with a bar on top. And we actually pronounce that x bar. So x bar is where the mean or the average goes. Now, everything else is going to be standard deviations above and below the mean, and this is the lowercase letter sigma, in case you're wondering. So that is a standard deviation symbol. In a standard deviation, what they do to find that is they take all of the data, they find out how far away from average the different responses are, and then they find that average. So it's kind of like, on average, how far away are the responses from the mean? So a lower standard deviation means the data is clumped closer together because things are not spread out from the mean. A larger standard deviation means things are further from the mean. And another way it can be used is also sometimes the data is some things are close to the mean and other things are far away, and that would also lead to a higher standard deviation. So going in the positive direction, each one of these lines is going to represent one more standard deviation above the mean. So the first line here I would say is x bar plus sigma, and that in words means one standard deviation above the mean. Have you ever heard them talking about the bell-shaped curve on the news or something like that? If you haven't had psychology, it's very commonly talked about whenever they come up with new studies about different things that they talk about on the news. You'll hear them talking about the bell-shaped curve sometimes. The second line here is x bar plus 2 sigma, so that would be 2 standard deviations above the mean. And the third line would be 3 standard deviations above the mean, x bar plus 3 sigma. And let's get to the area under the curve. So the probability between x bar and x bar plus sigma is 0.34. The next one is 0.135. This next one is 0.0235, and then last but not least 0.0015. So what that means is very, very, very few people are 3 standard deviations above the mean if our data is a bell-shaped curve. You will have to have these numbers memorized, so just be prepared for that. Going the other way, I'm also doing my mean and sigma, but now we're subtracting. So in words, that would be represented by 1 standard deviation below the mean. 1 standard deviation below the mean is what that would mean. Woohoo. All right, and then x bar minus 2 sigma, x bar minus 3 sigma. So 2 standard deviations below the mean and 3 standard deviations below the mean. My decimals here, and again, it's called the bell-shaped curve. It should be shaped like a perfect bell, though my drawing on your page is definitely not perfect. But all the decimals I had on the right side just transfer over to the left here. Make sure you have that in. Pause if you need more time. I just want to show you, if I add this together, if I add some of my probabilities together, you will see that 0.34 plus 0.34 is 68. So we say 68% of the data lies within 1 standard deviation of the mean. If I go out to 2 standard deviations, that would be 95% of the data is between, and 2 standard deviations between. Sometimes students use 68 and 95 to help them remember what these numbers are. So 95% of data is within 2 standard deviations. I'll abbreviate SD. And then if I go out to the third one, 99.7% is within 3 standard deviations of the mean, and the other 0.3% is outside. And if I take 0.3 divided by 2, that's how I get it would be 0.15%, which is 0.0015 in decimal form. Just so you know, if I'm thinking about area, I'm thinking about this shaded in. So think of the probability like an area if you're visualizing this. All right, pause if needed, and when you're ready, scroll down. I'll show you how we use this. Here's our first example. A survey shows that the time spent by shoppers in a supermarket, in supermarkets, is normally distributed with a mean of 45 and a standard deviation of 12 minutes. So, and we're going to have some questions here, but whenever I'm given some data, if I know that it is normally distributed, I can draw in my bell curve, and I am going to fill in my values. So remember, the middle value is x bar. They just told me that is 45. And remember how I said this second bar was, it's x bar plus sigma? If my standard deviation is 12, that means I want to do 45 plus 12. So that bar there is 57. And here, when I said it was plus 2 sigma, 45 plus 2 times 12, so, or just add 12 again, I get 69. Add 12 again, I get 81. And in this direction, I go backwards, so I'm going to subtract. So in my mind, I'm thinking 45 subtract my standard deviation. All right, so 45 subtract 12 is 33. And really what's happening is I'm just subtracting 12 each time now. So subtract 12, that's 2 times I've subtracted 12 now from the center. Subtract 12 again, so that's 3 times now I've subtracted 12 from the center. And this is really cool, because once you have that set up, these problems actually are really easy. So look at this. What percent of shoppers at a supermarket will spend between 33 and 57 minutes in the supermarket? So what I want then is I want this area right here. And because my data is normally distributed, all I have to do is add together the probabilities in the bell-shaped curve. So in the bell-shaped curve, those two areas are 0.34 plus 0.34. So 0.68. Now, read carefully, because if it does say percent, I want to convert it to a percentage, so I'll say 68% for my answer. Part B, what is a probability that a randomly chosen shopper will spend between 45 and 69 minutes in the supermarket? Okay, so this time I want between 45 and 69. So I want these two areas. And again, all I do is I take the probability, and that's why This bell-shaped curve is kind of like a shortcut. Every single time those probability numbers are the same. So 0.34 for that first section, and the second section is 0.135. So I just add those two together, and don't round this. Don't round this. If it's 0.475, leave it 47.5%. Don't round it. Write down any questions if you have them, and then flip to the back. Example 2. The price of a pair of sandals is normally distributed with a mean of $36 and a standard deviation of 9. All right, so to start off with, I want to set up my bell curve. So again, X bar goes in the middle, and then every time I add the standard deviation. So my standard deviation is 9. 36 plus 9 is 45. Plus 9 is 54. Plus 9 is 63. Okay, now I'm going to go the other way. 36 subtract 9 is 27. Subtract 9 is 18. Subtract 9 is 9. You will really get fast at setting these up after you've had a few practice tries. All right. What percent were priced between $18 and $72? All right. So you know what? 72 is off our graph, so we can assume that's part of that end tail. So between $18 and $72, so all of these areas, or I could just do 1 subtract those 2 areas. Either one would work. I'm going to do it the long way this time. So I'm adding together, and again, these are just straight from the bell curve on the front. So I add together my probabilities for each section, and I'm getting these numbers just from the front. Again, that's the beauty of the normal distribution. Every single time the probability between the mean and the standard deviation is the same if it has this distribution. That ends up being 0.975, and again, it asks for percentage this time, so I'll say 97.5%. Part B, what is the probability that a randomly chosen pair is priced between $9 and $18? All right, so that's just this section I just highlighted in blue. The probability, look on the front of your bell curve, is 0.0235 for that one. And notice this time it asked me for probability, so I'm just going to leave it as 0.0235. Now technically a probability could also be a percentage, so if you converted it to a percentage, it's not incorrect, but you just don't have to if it's asking for probability. All right, example 3. According to a survey by the National Center for Health Stats, the height of adult men in the U.S. are normally distributed with a mean of 69 inches and a standard deviation of 2.75 inches. Now, this particular one is actually true data. The rest of them were kind of made up by the textbook or by me. But this one's actually true data. So, guys, you can think about where you fit in on this curve. How many feet and inches would 69 inches be? Hopefully you personally know how tall you are. So think my X bar is 69. The standard deviation is 2.75. So every single time this way, I'm going to add 2.75. So I end up with 71.75 for the first bar. Plus 2.75 would be 74.5. Plus 2.75 would be 77.25. Going the other way, I am going to subtract. So X bar subtract my sigma. So 69 subtract 2.75 is 66.25. Subtract again, 63.5. Subtract again, 60.75. And again, I did that really fast, but I did this earlier. I just used my calculator to get those values. All right, here's where it's going to get a little bit more challenging. It says if you randomly choose 3 adult men, what is a probability all three are 71.75 inches or taller? So first of all, what would be the probability one man is that height or taller? And if I look at my chart, that's 0.135, 0.0235, and 0.0015. And when I add those together, I get 0.16. So the probability is equal to 0.16. Let me say greater than 71.75 is 0.16. Now here's the problem though. Now we actually made this a harder probability problem. I'm going to pick 3 adult men from a crowd. So again, think of what we did in section 12.5. If I'm going to pick 3 different men from the crowd, I've got 3 different probabilities for each of them. Or it could be the same probability 3 times, but I mean I've got 3 things I'm multiplying together. So the first man, and assume they're all independent, so every single guy, I've got a 0.16 chance of them being 71.75 inches or taller. So what's the probability of all 3? Now when I typed this in my calculator, and why don't you try it too, because I want to show you something right now. My calculator gave me a long string of numbers that looked like this, and I just want to say, if you're not clear yet, if we haven't, hopefully we've talked about this by now, but if not, remember that E is just your calculator's way of doing scientific notation. And really it means this. When I have got 10 to the negative third power, I move my decimal 3 places over to the left. So that ends up being 0.0041 if I round up. So I got to add zeros when I move that decimal point. So 0.0041 probability, or a 0.4% chance that all 3 of them are 71.75 inches or taller. Last but not least, example 4. I would like you to pause the video and try to see if you can set up your bell-shaped curve on your own correctly. Alright, have a look, see if it matches what you got. So notice again, x bar is 224, and then the other ones I use a standard deviation of 17. Okay, part A. What is the probability that between 241 and what is the probability that between 241 and 275 people attended the movies on a randomly chosen weeknight? So this one's back to the normal problem where they're just asking us in general. Let's say I selected one random person. So my 2 probabilities for those regions are 0.135 and 0.0235. Add them together. Again, please don't round. Give me the entire thing. There I go. Okay, part B. If I randomly chose 4 weeknights, what is the probability that attendance is below 207 for all 4 nights? So now, first of all, I want attendance below 207. So let's just figure out what that probability is for, let's say I was going to pick one night. What's the probability attendance is below 207? So again, these probabilities I'm getting right from what I have memorized or from my bell curve on the front. So I'm adding all 3 of those together. The probability of getting attendance below 207, less than 207, is 0.16 again. Okay, and now I have 4 nights of movies we're going to record data for. So what you got to think of is the 4 different nights, they each get their own percentage, again like we did in section 12.5. And when I multiply that all together, I end up with 0.000655 when I rounded it. So 0.0007 or 0.07% if you write it as a percentage. Alright, thanks for listening. Again, write down any questions you have and we'll talk about it in class. Hope you have a great night.